Hey, what's up? This is Monster Crafts, and this video is going to be a tutorial about how I use wire to make skeleton structures for my pipe cleaner crafts. The utility of making a wire skeleton allows me to make areas of limited mobility and create areas that serve as bending points for the structure. So things like knees, joints, wrist, hip movement. These things are outside the normal capabilities of pipe cleaners alone, and I've had a lot of success using wire in my crafts. I have a piece of wire here, which I'm going to be making the bare basics of a skeleton structure. Now for the ends of wire, I like to bend these inwards, so it gives a point where pipe cleaners, when you wrap pipe cleaners around the wire, they have a stopping point where they're just not going to fall off. So you make another cut at the end, and you also fold that bit in. This is going to form the basis of the spine of the craft. And we're going to make a triangle out of wire, which will form as a chest piece. And it will have 2 points of connection along the spine. So it doesn't move around. It'll be stable and stay in place. Another piece of wire here. We cut it, and then we bend it into the shape of a triangle. Next, we take the triangle piece we just made and attach it to the main backbone. This will serve as the frame of the chest and the shoulders, focusing on the 2 connection points with the spine so that it will stay in place. And we do that with pipe cleaner. It's best to wrap these individual pieces, in this case the spine and the chest piece, fully in pipe cleaner, so when you go to wrap them together, the pipe cleaner has more of a grip, because it'll be gripping other pipe cleaner instead of having the opportunity to slide along the wire. In the long run for crafts, it doesn't really matter, because there's going to be so many pipe cleaners holding it in place from all directions, because it's going to be covered with a whole lot of more material. It will stay in place for the most part. And for the hips and the attachment points for legs, there's going to be another triangle which is going to be reversed. As an example of what that looks like, I have a craft here that I'm working on. This one also has a triangle serving as the chest piece, but also has one that's flipped that serves as the waist. There is a space in between the 2 triangles that serves as the hip joint for the figure, so that when force is applied to the spine, it bends at 1 point. This allows for an ab crunch and also rotation. The next piece of wire will serve as the arm piece, and it will extend the length of the shoulders and both arms, excluding the hands. And this wire will be connected along the entire length of the shoulders. So think of it as similar to the chest piece and how it's connected at 2 points. To limit movement, this will be bound to the entire shoulder area. And the key is, when wrapping this to the chest piece, you want a slight bend in the arm wire. Because if it's straight, it can rotate freely, even though when it's bound to another piece. So if you bend it slightly, it will form almost as 3 points, mainly. So 2 on each side of the chest, and then 1 on the main spine. Now we have a shoulder joint. So if I apply pressure to the arm wire, it will bend at the connection point between the chest piece, the triangle, and then the rest of the arm wire. because that is the point of least resistance. Because the rest of it is connected directly to the rest of the triangle, so that's not going anywhere. So the movement of the wire has been localized to a select area, which is what we want. Now we are going to form the elbow joint, which will consist of a smaller piece of wire bent into a circle, and it will be attached at the arm piece of wire, or it could be the leg piece. It serves the same purpose. And that will essentially triple layer the amount of wire along the distance of the circle. Now we have 2 points of least resistance when compared to the length of the arm wire, which is covered by the circle. So when we now apply pressure to the wire, we still have that shoulder joint right there. But now we also have a smaller area down the length of the wire, which bends independently, and that could be considered a wrist joint. Now we're going to be looking at the Godzilla figure from, you've probably seen it in that 6-second short video I did, and then also in the longer stop animation. This is the first craft which I ever attempted to do joints, so it's kind of the rough draft for the system. Now it has 2 wire circles along the length of its arms and its legs. And this creates a shoulder joint, an elbow joint, and a wrist joint. So applying pressure to the wrist, it will bend the wrist, and then the next point of bending will be the elbow. Now another view here, it's greatly exaggerated, the separation of the 2 circles of wire. But applying pressure to another angle, it will bend at the shoulder joint. And this also has a system of 2 triangles, where it has a wire triangle for the chest, and then one lower down for the hips, which is mirrored. And in the legs, it's a similar system to the arms, where it's 2 circle wires that create areas of least resistance resulting in joints. Now the feet here actually have wire in them. I usually don't do wire in hands and feet in the ends, because usually those are just set upon in the pipe cleaner crafts. They just sit on their feet. But for this one, it does have wire in its feet. So you do get posable toes in this craft. Do with that what you will. And yeah, that's the extent of the wire skeleton and the Godzilla figure, and the whole reason why I made it in the first place. I made a lot of mistakes when making the figure, besides what I showed you, where there's too much wire that actually limits mobility in places that I don't want it to, such as the neck and then the tail. So again, it was an experiment. A lot of it was a success with the arms and legs, and the mouth came out really well. But other areas, there was too much wire, or wire in incorrect areas. So this craft was really impressive for the time that when it was made. It was pretty cutting edge, and it raised the ceiling for how big crafts can get. Now that they can sit on the wire, and they won't wiggle everywhere, and they'll bend at certain places, this means they can get a lot bigger. Now, the wire, however, used in this is a thinner wire than what I use now, and it's thinner than the one in the model I'm using. This is what I thought to be about the size limit, is this Godzilla, for this density of wire, which is about 0.88 millimeters. If you try to get bigger than this, the wire has issues and starts buckling. You can offset that by increasing the number of appendages around the ground. So like a bipedal will have a much harder time holding itself up than like a tripedal, like the Godzilla, or a quadpedal, like a horse or a lion or something. And here I have a snippet from the short motion video I made that shows a lot of the posability in action and a lot of the cool poses the craft can take to make it really look like an action figure. And here I have my latest build, the Bionicle Makuta Antraz, which has a much more refined system of the wire joints, and the skeleton is a lot more visible. First we have the arms, which is 2 single strands of wire running across the entire length of the arms, and they move together. Same thing for the legs. And we have the 2 circles of wire here. We have a wrist joint, so putting pressure on the arm, it will bend at the elbow. And we have the 2 triangles right here. We have a chest piece, and then we have a much smaller waist piece. And that's smaller because the Bionicle model has a very small waist piece. So just try and mimic that in this design. So here the waist piece is very small, but it is still a triangle that's mirrored from the chest piece. Flipping it over to look at the wings, this is a very versatile use of the joint system to create a structure that folds and bends as you'd imagine a wing would. So imagine a bat wing where it has the fingers on the end. That is pretty much what was done here. So the wing will bend in like this, and then it will also bend at what would be an elbow joint right in the middle of the wing. And then it can expand, retract. The wings can fully open and then recoil. And same thing on the other side. And this was the whole reason I made this craft. These came out extremely well. I used to use felt for the wing fabric, but I moved on to a material which is about 20% elastic I found on Amazon. And that works even better because it does have a little bit of give when you want to fully go to the profile of the wing. It will stretch a little bit. Also, it's easier just to get the sewing needle in than compared to felt, which is tougher. But these wings came out really well, and I'm going to use this design for other crafts in the future. There should be a link up on the top of the video that will go to the video that's a tutorial on how to make it. And it goes into greater detail about everything. Talking about the waist, we have a waist swivel because there's 2 triangles and there's a quite large bit of space in between them where it's just the wire by itself. So that whole area can bend. So you get a very generous waist swivel. And here it could technically stand up. It has the strength in the wire to do so, but because it's bipedal, it has a really hard time balancing. I guess a little funny of an example is we have Gyarados here, which has a complete lack of this joint skeleton system inside of it. It is fully articulable. It can bend any which way it wants because there's no pieces of circle wire creating areas of limited mobility to get a certain bend. It is all it's free balling. The only area that contains any wire is the head, and that was just to get that shape there. And then of course the head has the jaws made out of wire. It technically does have a swivel at where the back of the head and then the rest of the neck begins, but there's so much pie cleaner layered onto this, it lost a lot of that mobility, which is totally fine because it's going for Gyarados, not really expecting it to bend like that. Alright, and that's the video. I hope this properly explained how I use wire to create areas of limited mobility so that it will bend in the areas which I want it to bend, and generally mimic what you would think of an action figure and how that would move. Each tutorial video in the future will show the creation of the wire system, so it'll be reinforced there. There's no more questions. But again, this is just one way of doing it. This is how I prefer to do the skeleton system. I've seen other people use paper, tape, napkins, toilet paper, and then thin wire. I wouldn't say there's one really correct way, it's just however you want to make it.